Today we are diving into what I think is a really fundamental shift in artificial intelligence. We're talking about moving beyond AI that just talks a good game, to models that are actually starting to understand the physical world. And a brand new architecture from Meta, called V-JEPA, is right at the center of this change.
All right, so here's the plan for this explainer. First up, we're going to explore the huge difference between an AI that talks and an AI that actually understands. Then, we'll get under the hood of the V-JEPA architecture itself. After that, we'll look at how it perceives events in motion, and finally, we'll connect all the dots and talk about why this matters for the future of AI in the real world.
Okay, let's jump right into this first section, because it's really the core conflict here. The massive gap between an AI that can sound fluent and one that has any real grasp of reality.
You know, this quote, it just nails the problem, doesn't it? The chatbots we use today are so eloquent, so convincing, that it creates this powerful illusion of deep understanding. But what's actually happening under the hood is a completely different story.
So let's break this down. On one side, you've got your standard generative AI. Think of pretty much any chatbot you've used. They essentially think by talking. They figure out the answer word by word, token by token as they're writing it. But on the other side, you've got this totally different non-generative approach. This approach is about understanding the concept first, in complete silence, and then only explaining it if it's asked to. Right, so with a generative model, the process of reasoning and the act of generation of speaking are totally intertwined. The model thinks and talks at the same time. But what if they weren't the same thing? What if you could separate those two processes? Think first, then speak.
And that is exactly what V-JEPA is designed to do. It's not trying to predict the next word in a sentence. It's trying to predict a single abstract meaning vector from what it sees. You can think of this vector like a pure concept. It's the AI's internal thought before it even tries to wrap any words around it. Language just becomes an optional output, not the core thinking process.
This really gets us to the huge philosophical question that's driving all this research. Something Yann LeCun at Meta talks about a lot. Is being intelligent just about being really good with words? Or is intelligence something deeper, a fundamental understanding of the world? And language is just one of many ways we happen to express.
Okay, so that's the big idea. But how does V-JEPA actually pull it off? Let's get under the hood a bit and look at the architecture to see how it builds a more efficient model of the world.
Okay, so the full name is a bit of a mouthful. Vision, Language, Joint Embedding Predictive Architecture. V-JEPA is way easier. At its core, it's a non-generative model from Meta's AI Research Lab. And here's the key. It learns about the world by watching videos and predicting what's going to happen next. But, and this is the important part, it's not predicting the next pixel or the next word. It's predicting that abstract idea in its own internal latent space.
Now, this is where things get really fascinating from an engineering perspective. The efficiency. V-JEPA is achieving some really powerful results with only about 1.6 billion parameters. I mean, that is significantly smaller than a lot of the giant vision language models it's competing against.
And if you drill down even further, the actual brain of the operation, the predictor component, is even smaller, coming in at around 500 million parameters. A big reason it can be so compact is because it doesn't need a massive, power-hungry decoder to churn out tokens during the training phase. The whole process is just leaner.
And that efficiency isn't just about the model's size. It's also about speed. When you look at its performance on video tasks, V-JEPA actually learns faster than well-established models like CLIP. And it makes sense, right? Trying to predict an abstract concept is just a much more direct, more efficient path to understanding than trying to predict long, complex sequences of words.
So all of this efficiency unlocks what is, for me, the most compelling part about V-JEPA, its ability to truly understand actions and events as they unfold over time.
Okay, check this out. This visual really shows you what's happening inside the model's head. Each of these dots represents what the AI thinks is going on. At first, you see these scattered red dots. Those are its initial, uncertain guesses. But as it watches more of the video and sees more frames, they all start to converge and lock in on that single blue dot. That's it. That's the moment of confident understanding.
So what does that mean in practice? Well, a standard vision model would look at a video one frame at a time, and its labels would be jumpy and inconsistent. Bottle, hand, canister, it's just reacting to what's in front of it in that split second. V-JEPA is different. It builds a stable idea of the entire event and says, I see what's happening here. Someone is picking up a canister.
You can really break this down into a simple four-step process. First, it observes an action. Second, it forms a quick initial guess. Third, it keeps watching, gathering more frames for more evidence. And fourth, once it has enough information, it confirms and locks in its understanding. Simple as that.
So the real magic here, the absolute killer difference, is time. A simple model is stuck in the present, just looking at one static frame at a time. It has no real sense of before or after. V-JEPA thinks in temporal meaning. It understands the whole story, the beginning, the middle, and the end of an action.
Okay, that's really cool from a technical standpoint, but so what? Why does any of this actually matter? Let's connect these details to the real-world impact and the future this could enable.
Well, it matters most anywhere an AI needs to interact with the messy, unpredictable physical world. We're talking robotics, autonomous systems, wearable AI, and any system that needs to do real-time physical planning. All of these things require an AI that has an intuitive grasp of cause and effect, and that's exactly what this approach is building towards.
And this quote from Jan LeCun just sums up the current paradox perfectly. We've built these incredible AIs that can pass the bar exam, one of the hardest professional tests out there. And yet, we still can't build a domestic robot that can reliably do the chores. There's this massive gap between textual intelligence and physical common sense. LeCun's argument is that this gap exists because we're training AI on the wrong data. Think about how a human child learns. They don't spend their first few years reading Wikipedia. They watch things fall, they interact with objects, they learn about gravity and physics just by observing. That direct visual interaction provides a much richer understanding of how the world works than all the text on the internet combined. And that is the true foundation of intelligence.
Now, let's be real for a second here. V-JEPA is not perfect, not by a long shot. It's still very much a research project. Users have pointed out that it still makes mistakes, it misidentifies actions. This technology is still very much evolving.
But, and this is the key point, the significance of V-JEPA isn't about its perfection today. It's about the direction it's pointing us in. This represents a huge philosophical and architectural shift toward building models that learn about the world in a more fundamentally human-like way.
So, if you remember one thing from all this, let it be this core analogy. A generative LLM is like a narrating student who has to think out loud, word by word, just to figure out the answer. V-JEPA is like a silent analyst who just observes, understands the whole picture first, and then speaks, but only if necessary.
All right, so let's just quickly recap the three big ideas here. 1. V-JEPA is non-generative and highly efficient. 2. Its key strength is understanding events as they unfold over time, not just in a single snapshot. And 3. This represents a foundational shift for any AI that needs to operate effectively in the physical world.
Ultimately, what we're looking at here isn't about building a better chatbot. That's really not the point. This is about building a better foundation for intelligence itself, an intelligence that's grounded not just in language, but in a deep, predictive understanding of the world around us.